Okay, for those people online, if you're able to hear me, all right, just drop me a thumbs up, yeah? Yep. Carol, Skylar, if you're able to hear me, please drop me a thumbs up so that I'm aware. All right, thank you. Okay, we'll just wait for a while for the crowd to stream in before we start. Okay. Okay. Huh? Have a seat. How are you today? Not good? Oh, I heard not good. Okay, okay. Good is a good thing. Yeah, can just chill lah. It's gonna be a long one for you as well today. You have the material, Kina? Yeah. Okay. Yep, come in. Hi. Can I get your names? Okay, three of you. Just let me check. Just four. Oh, four. Okay, wait. Four. Okay, let me search. Do you have the materials with you by any chance? No, I don't. Oh, okay, no worries, no worries. I do have a lot, so not to worry. Okay, no problem. Okay, so wait, Jen Yao, is it? Jen Yang. Jen Yao. Where is it? Is it me or I don't spot your name? Okay. Then maybe I get the other three first. Okay, I saw this. Okay, Josh Xia, right? Wonder Josh. Isaac? Okay. Okay. No, 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 it's no, it's just maybe I forget to highlight and stuff. Your name is? Jen Yang. Then last name is Hui. Hui. Okay. Okay, never mind. Let me use the power of Hui. How to spell? Hui. Hui. Yeah. Oh, not this one. Never mind, never mind. It's okay. No, wait, chill, chill, chill. I'm not gonna chase you or anything. Relax, relax, relax. Yeah, at most we just sit outside. I'm not joking. Wait, you are Lai Xiu. No, 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 this one. Sorry, sorry. How come I cannot find your name? I got the email though. I can just show me. It's fine. It's okay. You show me. I okay can already lah. I very chill one. You all no need to stand here and 罚站 eh. You all got the material already? Yeah, that's me. Yeah, yes, you found me. Eureka. Yes, very good. Yes, yes. Okay, no problem. No, it's no, it's I'm not gonna chase you or anything. I not so 鸟急 no. Okay. Just need to don't have your name. No, 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 it's okay, it's okay. I'm not gonna chase you out. No, 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 no. No, I must say. Oh, Jen, yeah. Okay, okay, can. Okay, okay. Let me try to find. Do you have the material? All of your? No. Not really. Okay, never mind. They might have. It's okay. I will just add you somewhere. Okay. I got a lot lah. Okay. Alright, let's find a place to sit. Thanks. No problem. Please take a look and Right, one, two. Quadratic equations discriminant. Hello, all right, come in, come in. Hi, can I get your names? Right, I think just the names. If I can find, it's okay. K A. Oh, okay, yes, and okay, can just take a seat. Do you have the materials? Okay, you all never collect, is it? Ah, it's fine. No, yeah, I'm not gonna score anything. Just ask me. I two of you very familiar. There you go. Yeah, just have a seat around. Free sitting, free sitting. Yeah, we just wait for the crowd to stream in. Hello, can I get your name? Yuan. Oh, okay, I cannot find your name. Do you have the ticket with you by any chance? Yeah, just show it to me, lah. It's fine. It's just sometimes maybe they didn't register, so it's okay. Oh, wait. Tan Yuan Kai. Okay, got it. Okay, do you have the... Oh, you all never collect one, ah? Okay, it's okay, it's okay, it's okay, it's okay. Relax, relax, relax. I have a lot here, so not to worry. Okay, here you go. Let's take a seat. We're gonna start really soon. Oh yes, I forgot. Yes. Oh, okay, can. All right, y'all just chill a bit. We wait for the crowd to come in. Then we start about 6:30, 6:35. Yeah? Yes, yes. All right, for those online who need a soft copy, I'll just send it in the chat. Just feel free to download from there. Yeah? Sorry? Oh, up to you, man. I love your spirit. Yeah, yeah, go ahead. You need the washroom, right? Yeah, go, go, go. It can be either. It can be sign at the top or sign at the bottom, but just make sure the corresponding angles and the side are opposite each other. So, example, if you look at the particular triangle, in this case, where I'm looking at is, I don't know, what's that? Give me an alphabet there. Just point to an angle. A, right? So basically A, that side opposite A, that will be the ratio you're forming. You all don't have to do first, don't worry, but you all are a bit N2, so you all can do first. I bet you one. Okay, I have more people. Hello. Hey, can I get your name? Okay. Okay. No, 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 it's okay. I just need your name. Pun right? Yeah. Do you have the material? Okay. Yes. You didn't collect it? Okay. Just take a seat everyone. Okay, I think crowd roughly coming in. Okay, I'm gonna start about 1-2 minute time, so make sure you all ease yourself down, yeah? Ah, yes. Come in. May I have your name, please? You're here for the IP math, right? Yeah. Just come. Yeah. Can I have your name? May I have your name? Sorry? Le Xuan, Diao Le Xuan? Awesome. Do you have the material? Awesome. All right, just get a seat and then, yeah. All right, okay, you know what? Let me just start off now. I think I would say I have, if not half or most of you are here, but I think I'll just start off first. Okay, let me close the door. Thank you. Okay, so you all know the formalities. Let me just go through a little bit, yada yada, 5 minutes or so before I go through the content, okay? So thank you for coming to this September holidays EOY revision event with me. Okay, understand that it's not very easy to wake up, or eventually if you just woke up, some of you I know some of you, or maybe I know of some who just woke up, or maybe spend your evening with me to go through this 3 hours worth of torture, I mean a learning session together. Okay, so hopefully you all get something from here lah, regardless of whether you get something from here in summary. Okay, so if you're wondering who is this teacher here teaching, okay, some of you all might have seen me before if you are in other classes. So my name is Jason. Okay, there's another Jason, so that's why the surname here, Mr. Yek. Okay, you can call me Teacher Jason, Teacher Yek, Mr. Jason, Mr. Yek, or today, if you don't feel like, I somehow suddenly got dementia, forgot my name. Just fix my name, call me Chia. If you've got any questions, I'll be more than happy to assist you in any queries. Okay, subjects I teach, basically in summary, I conquer all levels, Sec 1, Sec 2, Sec 3, Sec 4, and IP Math lah. Okay, nothing above, nothing below, just right in the middle. Okay, secondary school lah. So in terms of credential wise, okay, in summary, I will not blabber too much. Graduated from NUS in mathematics. Not because of that, that's why I'm a math teacher, but it's just a coincidence. Okay, see, teaching for 6 years already. Okay, the 70% over here is a double effort lah, I would say. I know some of you will feel like this is like a buffer number. I kind of agree as well. This 70% over here is really like a one-to-one effort. So I try to make sure you understand. You try to make sure that you question me and make sure you understand as well. Because I don't want you all be here, oh, this question is like this. Then after that, you just follow and listen. No. Any part not sure during the lesson, I advocate, just ask. Okay, cool. I really advocate you all just asking me. Even though on the day, maybe you all very tired, you all want to ask me, Chill, why 90 plus 70 equals to 150? I'll just tell you with them check. Please press your calculator, find the value. Really, that's it. Okay, that's the feel I have for all my lessons as well lah. Okay, cool. So in this case over here, just a fun fact, a bit of a shameless part on my side as well. Okay, so I do have a social media account to actually go through my teacher journey. So if you are interested, if you feel like following, it's literally there lah. Literally, Jason Ye, in front teacher. Go search in IG if you want to follow. I'm not gonna promote that. Okay, now next one over here. In summary, over here, the reason why you are here is that you know us either through Telegram, Instagram, or YouTube lah. 9 branches, we have a lot of students, and yeah, that's where I'm sharing the love for you all in this place here on Novena. Okay, cool. Now, next one over here, yada yada, we have 70% of your us scoring the distinctions, but then again, all these things come about because of the double effort. Okay, it's not me trying to be a lecturer, just pam, you being a sponge trying to absorb and then come out, everything will be gone. No. Again, I always advocate double effort. I will convey any parts not sure, just let me know. Okay, so in this case over here, I think I've seen this slide quite a few times for those who have attended, but in summary, if you are an overmarked student, you get all of this. The only thing you won't get for math is these two lah. Okay, you want practical notes? Please go somewhere, or unless maybe they decide, oh, 2 years later we're gonna have math practical. Okay, touch. Let's not have that happen lah. Okay, any questions? All right, if not, I think time for the content to begin, yeah? Okay, so in this case over here, we're going to cover 3 aspects for you all. If you wonder trigonometry, I know some of you all flip, and I'm aware also, I walked around and based on my surroundings, you all see trigo, you all get shocked. The shock part is for this one, maybe not so much because, okay, if you understand what I'm saying, we are not going through this thing called the ASTC quadrant yet, okay, because focusing on trigo 1. But let's say along the way, maybe if I want to give you some break time, if you have some questions about that, feel free to ask me. I'll be more than happy to assist you within this 3-hour time span. I won't say lifespan, yeah, time span. Okay, after trigo, then we'll focus on, my memory is lost. Remainder and factor theorem involving polynomials, partial fractions, and then the last one will be on quadratic equations. Okay, just these 3 aspects over here. Okay, first part will be a review. Okay, I will just touch and go, but any parts, if it feels very foreign, all right, please let me know. Okay, or you never see before, or you wonder why is it like that, please let me know. Okay, now let's get started. First one over here, okay, there's a bit of a printing. I don't know why the we have is like this, but okay, it doesn't matter. Okay, left-hand side is what you all love in trigo. When the days of trigos are very nice. Why? Right angle, you just need to remember, tuakaso. Correct? The letter on the left is basically your trigo part, your tangent, sine, and cosine. These parts over here are your opposite and adjacents. Basically, the sides of your triangle. Okay, tuakaso. Then after that, you may begin and ask, wow, suddenly got this sine, cosine, tangent, and then you realize, how come, why does this ratio hold? Now, before I go through this and say this is the formula, before I go on, how many of y'all, I rephrase, are not aware of the ASTC quadrant? Not aware. All aware? Because with the ASTC quadrant, I can essentially tell you it is because of that or these 3 formulas hold. How? Acute angle. Okay, very quick one. ASTC. Acute angle, or in this case, your obtuse angle. Do you all agree in this case because of how I label? 0, 90 degrees, 180 degrees, 270, 360. Because it's acute, it has to go this way. Anti-clockwise. This is your angle when it's theta. No problem. Yeah, just take a seat somewhere. Yeah, at the front, but it's not. Okay. Now, as a result over here, do you all agree that my basic angle will be 180 degrees minus theta? Correct? Acute angle, which quadrant does it lie in? S, right? S quadrant, what does it tell me? Only sign functions are positive, right? So basically, if we were to refer to the ratio I have, and my pen decides to die on me, give me a moment. Okay, only sign functions are positive. Okay, give me a moment. Okay, only sign functions are positive. That's why if you look at my ratio, only sign functions are positive. The other 2 are negative. That's it. So that's why if you look at acute angles, based on your ASTC quadrant, really that is the relation. You all can try with your calculators as well. Key in sine 50, 150 into your calculator. You're going to get half. Key in sine 30 in your calculator. You're going to get half. This means that in terms of the ratio, they will hold. You can do the rest for the other 2 as well. You're going to get weird decimals, but all in all, it will hold. Okay? So specifically for sine, you have to take note there will be 2 angles that gives you the same positive value. So this one, you have to check whether it gives the acute or obtuse angle. Okay, just some things to take note. Okay, since you're all here, maybe I share a hack. How many of you all have troubles remembering your exact values for your special angles 30, 45, 60? It's okay, just share. How many of you? Don't be shy, just share. Thank you for honesty. Just share, raise your hand. Yes. Thank you for being honest. Now, what if I tell you? Now, what if I tell you you don't need to memorize? Yeah. What if I tell you you don't need to memorize? Because all you need is this. Why? Example, one value you all struggle. This one you all key in your calculator now. Take out a calculator and try. I want you all to key in sin 60. Okay, make sure your calculator is in degrees. This is a special hack since you are here. Now, sin 60 you all key in. You all going to get a string of decimals, right? Make sure your calculator is in degrees. Sin 60, key in. You all will get a string of decimals. You'll be like, okay, so what? Now, the key thing is this. Sin 60, all right, you all get a string of decimals. What I want you all to do now, can you square the value for me? Can you tell me what you get? 3 over 4, right? Thank you very much. So this is 3 over 4. Since I square this, I get 3 over 4. Can you tell me, in this case over here, how do you think I can get the exact form? If you, from here, just manually square root. Sorry, do me a favor. Yeah, thank you. Do you realize by manually square rooting, you have your exact form? It works for 30, it works for 45, it works for 60. You can try. Tangent 30. You are going to get 1 over root 3. Basically a string of decimals. If you square, you get 1/3. Square root it is basically that particular string of decimals in your exact form. So it will work for all special angles. Okay, so by right, I don't think I'm intending to share this, but since you are the realm of trigo, and I'm hearing so far that you guys are struggling in this, so I'm just sharing this part. 30, 45, 60, this technique will work. Square root, done. Okay, you are just manually square rooting this particular part. Okay, so now with this hack, you can relieve your memory of your mind for the special angles. Okay, it will work for all calculators. Just make sure it's in degree mode. Don't do in radians. You do in radians, your values are going to be very weird. All right, cool. All right, let me move on. Okay, awesome. Okay, now moving on. Now, when we talk about these formulas over here, when you see and be like, oh, okay, I have seen this somewhere. I have my half AB sine C, but recall what do they mean first. These formulas, AB sine C. Long story short, AB are your sides with my angle that has to be sandwiched in between the sides. I repeat, you didn't hear me wrong. This has to be sandwiched. Okay, so as long as you know the two sides, you find the angle that you know, it has to be sandwiched. Okay, and also as a result for non-right angles, and specifically, I should not say non-right angle actually. This is actually more for, let me bracket any triangles. You can use this for right angle triangles as well. Okay? Quote me correct, okay? You can use this for right angle triangles as well. Okay, let's say if you forget. This one, sine rule, cosine rule. How do you remember? Same analogy. If you look at the way that the ratio is written, say I'm just looking at this part. Okay, I know you all know the formulas, but just to recap how these formulas and how you put in the values. This value here and this specific angle, they have to be opposite in sides. So basically, if I'm just talking about this ratio here, they have to be opposite each other in order to apply. Okay, and of course, if I have all my angles in one row, all the sides have to be one row. Similarly, over here, sides one row, angles one row. Cosine rule as well, okay, two concepts apply. One, if you want to identify what is my C square, this one and this particular angle over here has to be directly opposite. You can identify from your triangle that was drawn there. A square, B square are the ones that's included. That's how you get the formulas down. So in a way, how you note these formulas is just this part and the understanding as well. Now, as a result, do I need to know this? Again, if you want to make it convenient for yourself, go ahead. But since these three are provided, just work with these three. It's fine. I don't expect any form of memorization at all. If you can rely on the formula booklet to apply, you do so. That's my analogy over here lah. Okay, Ken? Cool? Okay, any parts not sure, just give me a shout, okay? I will make sure I'll answer your query accordingly. Okay, as long as related lah. Next up. Now, when we talk about this particular trigo over here, there are, in this case, two things that we need to talk about. One is going to be your elevation and depression for the angles, not your mental state. Okay, is this particular part over here, when how we talk about elevate and depress is really the notion of, if you want to talk about elevate, this is where you look up. That's why elevate, you are looking up. So that's why the angle we are looking for is this particular part over here. We are looking up. Elevate, looking up. Depression. Okay, I'm depressing my head. I'm looking down. That's why the angle goes down. Okay, and the phrasing in this case over here for such questions, usually it will be of the notion of something from something, of A from B. In this case, we are looking from, the part where it's from is going to be your starting point. From where, it's where you start. Okay, I'm doing a quick one here, yeah, so that you all can take note. Okay, these are just some quick pointers for you to get it down. Okay, now, bearings. This one will be quite confusing if you mix up with your ASDC quadrant. Why? ASDC quadrant, your angle goes anti-clockwise, right? This one, your angle is going clockwise. So be very careful. The two things are different. Okay, generally what to take note is measure in degrees and 3 digits. Okay, what I mean by 3 digits, if you take a close look, even though here is 60 degrees, I need to write 060. Cannot write 60. You write 60, mark down. Okay? Where is it starting from? The north line. And in this case, it goes clockwise. Okay, keyword here, I'm looking for clockwise. And it must start from the north line. Phrasing is as the same lah. From where, that is your starting point. Same as your angles of elevation. Okay, so over here, I really just touch and go because you should be familiar. But any parts not sure, please let me know. All good? Can. All good? All right, awesome. Now, with this work example over here, all right, I'm not just going to jump into the solution. I want you all to look at the solution and wonder why are the solutions crafted this way. And in a notion, for such questions, when you are doing, always relate back to the info given. First one, calculate BAC. In this case, you are calculating this angle. Now tell yourself, usually for non-right angle triangles, you only have two rules you will want to utilize. Either sine rule or cosine rule. Only these two. Don't wander too far. Sine rule, usually we will use when we have more angles involved because you have your ratio and angle, ratio and angle. Cosine rule, you will try to use it more when you have more of the distances involved, or in this case, the lengths involved. So that's why if you take a look, which one will correspond for part 1? If you want to find BAC, okay, in this case over here, this particular angle, you realize, okay, I will use the cosine rule because if you filter in, you have all the lengths. The way I craft it, as usual, don't just hum your numbers in. Check. I'm finding BAC. What's the side opposite? 55. That's why 55 is here. This one is here. The other two are the lengths that are actually surrounding the angle. This and this. Okay, Xavier asked a good question. Okay, 25.25, you write the decimal. Okay, good question to take note. Let me revert back to bearings. Now, let's say if you have a decimal, okay, in this case, 2.5, my digits will be for here. Any decimals you must write down. So example, 62.3, you must write 062. 0.3 is not a digit. 0.3 is not a digit. Anything after the decimal point is not a digit. I repeat myself. Digits are positive values before the decimal point. Okay? Why is theta acute? Yeah, in this case, sorry, I'm just answering the online one. KJ, I'm just saying that theta is greater than 90 in this case. You can switch the things around. Yeah, sorry to neglect you all. You can switch the things around. Okay, so if you want, in this case, let me backtrack again. If you want your theta to be this one will be 180 minus theta. I'm just switching around in this case and assuming theta is acute. Okay, sorry for not looking at the chat, yeah? I hope I've answered them. Okay. Okay, and backtracking over here, just check part 1, this is how we find lah. Okay? Okay, so I want you all to understand the solution and check how we find. Now, DAC, check. Where is DAC here? DAC is this part. Now over here, if you want to find DAC, look at the triangle that is associated with DAC in this case. What rule can we use? Okay. Of course, if you actually look at the answer, we have more lengths, but in this case, not all lengths are given, one specific angle. So we can use sine rule, but our sine rule over here, sometimes we may not need to find the thing directly. Okay, if you realize why I cannot work with it directly for this case, directly opposite here, don't have number ma. You want to whack also cannot whack. So what you do? You want to actually whack down the value, you make use of what you have. In this case, you have 60. These two confirm can use because they are really opposite. What you can find over here is if you were to use it, you can actually find this angle, and from the angle that I found, which is ACD, which if you refer to the workings that I have, we can directly find this one already ma, because we know all angles in a triangle is 180. 180, we subtract this angle we find, we can find this one. Which is essentially, okay, over here. I am not finding the angle directly. As mentioned, if you refer to the diagram, I'm finding this angle first. Which you will work it out, make sure your calculator correct, punch in, and trust yourselves. This is the angle, ADC. Working out over here. So sometimes you can find it indirectly first. Okay, to help you find it out. Okay, can okay, third one. Bearings of A from D. Now, this one you have to be very careful. Check where your north line is drawn, because sometimes they will play a trick. Your north line sometimes not straight. They will draw sengek one, left, right. Must check from the diagram. A from D. In this case, just nice, your bearing is drawn this way, so draw it up. Sometimes good to give it a label. A from D. Now ask yourself, where's my bearing? Okay, then you may wonder, okay, very nice. How do I even start? Usually in this case, we will want to make use of the angles that we have found previously. So from here, you can backtrack. Okay, DAC over here, we know this value is, let me just write down, 49.324. Okay, DAC over here is going to be 63.183. Now, you realize in order to find this particular, D from 8, sorry for that. It should be one whole route, my mistake. D from 8. I'm finding the bearing of A from D. So sorry, yes, it should actually be this whole route. Yeah, it goes all the way around, my mistake here. Now, one thing is this, there's a reason why the question is in parts. You are making use of what you have found to help you out for the bearing here. So that's why if you see the working, the reason why you have alternate angles, if you relate back, is recall, if you have parallel lines, remember these three things. ZFC. Alternate, corresponding, interior. Okay? In this case, this doesn't look like a Z, but if I flip it around, essentially it's these two angles add up, and I will get the addition here. Let me just refer 112507. Okay, it's just adding up these two angles here. After that, if you want to find the bearing, angles at a point, relating back to your basic geometry. That's why you subtract. Okay, that's why I'm not really prompting because all is written down. Just roughly, we just want you all to see how you relate back to the question. Okay, can Okay, last one. This kind of long style question, last one, they will ask this. Something related to angles of elevation. So for this one, you just have to check where is the angle of elevation lying at. So you're working northwards for point A. Okay, I'm placing on point D. So relate to the question, refer to your diagram. I'm walking northward for point A. I'm etching a pole here up. So if you realize as I work northwards, relating to your triangle that I've drawn for you on the notes, okay, I want to find, in this case, the greatest angle of elevation. So the only way to have the greatest angle of elevation is when you have a right angle over here. Because right angle, that's where you have the shortest distance. Okay, which I've drawn your triangle at the exact page where the workings are. I kind of label this as X. Okay, no need to draw on your side. The triangle is drawn there for you. Okay, in the working, it's right there, like on your right. If you refer to your workings, like, yeah, you're staring at it now. Yeah, this one. Okay, so no need to draw. Everything draws sweet already. So what I'm drawing here is related there already. So really, we are finding our shortest distance, but, okay, the only angle that is missing is, you realize, if I want to find this side, two things. One, Pythagoras. Two, trigo. Right angle, you realize don't have all the sides. Most likely is trigo. If you relate back, this angle over here lies, okay, on the straight line of this part here. So the one I'm finding at your diagram is the one I'm showing you now. Can So that's why in this case, when I'm subtracting, I'm really taking out all the angles and subtract to give me, sorry for that, this angle here. Sorry, this door not auto one, must close. Okay, once you have this, you realize basic trigo lies in sine XAD, okay, Y sine, opposite hypotenuse, take note, I'm finding this one. Okay, after that, you can find dx. Now, what is that purpose? That is the shortest distance where you are getting your greatest angle of elevation. Okay, how it works? You are over here now. The pole is here. You are looking up. No need to draw this diagram. Drawn here for you. Greatest of angle of elevation given as 7 degrees. So we know to find this, usually we use tangent, usually, okay, opposite, adjacent. Okay, so this is a very rough gauge of how I go through the solution, but there are questions coming up, not to worry. This is where I will enforce it further. But as of now, anything you want to ask, just shout it out if not sure. Hello? All good? Okay, now, first one. Diagram shows this part where you have all these lengths here and one angle given. I want to find now this particular angle. Now, remember I say when you see a triangle like this, if I want to find the angle, either sine rule or cosine rule. Take a close look for this one, just thinking in your head, okay, which rule will be suitable? Anyone? Sine rule, okay, got it down, awesome. So sine rule, depending on what you want to write, the convention for me is this. Whatever I am finding, to make it safe, I will write it at the top left-hand corner. So that it's easier for me to track that particular value. Okay, over the opposite side, which is 109. This is equals to find my direct pair. In this case, sine of 48.1 over 87. Okay, my direct pair is here. My direct pair is here. After that, do your necessary multiplication. Sine BAC is equals to, just multiply my 109 over. 109 sine of 48.1 degrees over 87. Okay, but you realize this one, if you straight away take the sine inverse, you're not going to get an answer. It will give you an acute. Calculator will always give you an acute answer. So if you want the obtuse answer, we must do something to this particular angle. What must we do to this particular angle after we take the sine inverse? Anyone? You can mumble to yourself. Maybe I know some techniques of ventriculism. Hopefully I can read your lips. Okay, but just roughly thinking, I must do something to this particular value. Because if you take your calculator and punch this, you are going to get an acute angle. I want obtuse. So what must I do? Okay, recap
180
it.
minus
We call the
your
hint
angle.
here. Give you a hint. Sine 30, sine 150. Both of them are the same, right? But one of them is the acute angle. One of them is the obtuse angle. How are they related? If one of them is the original one, the other one will be you must do 180 minus this particular angle. This one, regardless how you key, you are always going to get a acute angle. Okay, but make sure it's in degrees. So when you key in, you punch in, you get the values, you get 111.1675. Remember your values in degrees, 11.2 in 1 dp. By right, my equal sign should be below, but I kind of made my handwriting too big over here. Okay, any questions? Okay, you can key in the calculator to confirm your values. And usually what I like to do is this. Once I find a particular value, I will write it here so that it's easier for me to spot. Okay, can okay, make sure you read and understand the content here. Any parts not sure, just ask. Even anything that's unclear, working wise, why the sign rule is like this, please ask. Okay, can now next one. Hovering above greatest angle of elevation. Typical style. this will keep coming out. Greatest angle of elevation as she cycles along BC means as I'm going along this part here, I want to make sure that I have a perpendicular distance here. Same concept holds all along. Okay, greatest angle of elevation, I am making sure that this is the shortest distance from A to BC in this scenario. And then always remember, shortest distance is always going to be perpendicular. Now, one thing is this. In order to find this particular distance, there are two ways. One, we can use the area of the triangle, but too much of an effort here. The other one, we can use basic trigo. How? From here, we have one of the lengths here. This one, we only have one angle, no sides given. We have two of these angles. This one, we can definitely find easier. Angle sum of triangle. 180 minus the red one minus 48.1. Okay, so you take your calculator, press it. This is going to be a value of this. Okay, this is, okay, you were to trust me, just key in your calculator, press it. You're going to get 20.7325. Okay, just pressing 180 minus this value minus this value. Again, this is to track your thought process here. Now, with this triangle here, how would I find the shortest distance? If this particular view, this perception is hard for you to find, don't keep doodling on the diagram. Already got one arrow here, you don't see until you confuse. You have a lot of space. Draw out somewhere. Okay, your shortest distance, just draw it out. In this case, this is your A, this is your C, just draw accordingly. A here, C here, all right. Draw out another triangle so that you can see clearer. This is the angle that we have found just now, which I'm going to write the working later. AC is 87. Okay, how did I find in this case the angle? Okay, so let me just write down the previous working. BCA is 180 minus triple of 1, 1675 minus 48.1. This is from the previous working, yeah? Okay, and for the calculator input of the calculator, it is how the calculator is functioned. We call it principal values, but you don't need to know. Okay, it's just when you key the particular ratio into the calculator, it will guarantee you an acute angle. Yeah. Okay, now over here, take note. This is your shortest distance. So what ratio do we use here? Sine, cosine, or tangent? Okay, slowly think about it. Okay, if you want to mouth it out, shout it out also can. What ratio do we use? Okay, sine. I heard sine. Very good. So sine of this angle. So let's label this angle. Okay, let's say this is x. Let's say this is x. Okay, I'm just labeling. So sine ACX. Okay, I know what's ACX, but what I will do, I will want to actually label according to the alphabets first. Then I will label what is in the diagram. Okay, AX is what I want to find. AC is 87. Okay, take note, AX is my shortest distance. So over here is this. Now for this type of questions, once you're writing and solving, you will need to draw quite some triangles. So the triangle I've drawn, the goal we found is the shortest distance. But that is not enough. What we have found, okay, once you have written down, I'll give you some time to look at this. I don't want you all just to write and look up and write. Okay, this is the part we have written here. What we have found is the AX. What does the AX represent? If I scroll up, this is my AX. This part, I'm looking up to a helicopter that's hovering. If I draw like this, it's going to be very confusing. So please just draw at a separate diagram. I am at X, A. This part, I am at X to A. A helicopter is hovering 239 meters above A. AX, we just calculated, is this one. Control C, Control V. I want to find the greatest angle of elevation. Elevate up. So that's why in this case, the angle I'm working with, respect to the angle, basic trigo, this is right angle triangle, opposite over adjacent, this links to tangent. Okay, my opposite is just 239. My adjacent is 30.79846. Apply your trigo of this part. You will get this value. Okay, you can key in your calculator and trust and to make sure you have some trust there. And this one. Okay, I will write and stop here. Let me know if there's any queries. Okay, look through the working and understand. I don't want you to just look through and then, okay, I'm done, move on. No, let me know if there's any queries. Just feel free to ask. Just ask. You have a question? Just ask. Yes, no, yes. Yeah, can. I very sure. Eat. Yes, please. Anyway, if you all want to munch, just go ahead. Just make sure you don't buffet mukbang here, okay? Yeah, if you are hungry, want to take a snack, just go ahead, really. I okay one. Yeah. Hey, besides that, any other questions? All good? And yeah, very chill one lah. But just make sure you all can understand my content. That's my goal. And of course, yeah, all good Okay, all right. Next few questions you realize are going to be the same particular thread. What do I mean? I'm going to give you a diagram. You're going to use your sine rules, cosine rules, and try to work out all your different angles and different sides. And last one, you're going to whack is angles of elevation. Okay? You have a diagram like this. A, B, C, D, horizontal line. Town A is due west. Keyword over here, if I say is due west, okay, in this case, know your north, south, east, west. What can I say this angle is? Very good, 90. So we can take note is 90 lah. Awesome. Okay, we just take note lah. They give that got reason one. Okay, let me color code it nicely lah. Okay, ABCD is a trapezium such that AB is 0.9. Basically, whatever the diagram didn't substantiate, you substantiate. Whatever info is written, you make sure it's all here. 8. Calculate the distance between town B and D. Not stated in the diagram, draw a line to visualize. Now, what rule are we using here? Okay, look at it. I think you're aware. Because just nice. Two sides, one angle. See which are the values you can put in to the formulas. You want to use sine rule? Make sure you have two angles. Okay, in this case here, I know you have mentioned in, okay, take a flip look, think about it. This will be your cosine. The distance is BD. So it's going to be B square plus C square minus 2BC cosine. Again, the rationale holds BD and this angle directly opposite. These two are sandwiching the angles. Okay, Key this in your calculator, work accordingly. You are going to get a wonderful value, 4.1061. Okay, you realize my values, I tend to write a lot. How much is enough? 5 to 7 significant figures will do. All right, this is to prevent rounding error. I know some of you are a little bit cautious. You want to write all the calculator values, but it's too long. So just tell yourself, this is not the one in the calculator. I just truncate it, 5 to 7 significant figures. After that, if you want to find BD, it's really taking the square root of the above. 3SF for final answer, 203 km. Okay, so sometimes what I like to do also, once the distance is found, I write it on the diagram to give my diagram a little bit more detail. So it's easier to see. Okay, now next one. Before I go too fast, any questions on this? Next one, find angle BDC. Check from the diagram. I'm finding this angle. Then you may realize, oh, I cannot find anything from here. Because this particular triangle, if you were to zoom in and see this one, there is nothing I can use at all. So that's why I have to take a look. It is mentioned that this is a trapezium. So instead of finding this directly, what other angles will help me find BCD straight? Okay, we call trapezium property. I have a pair of parallel lines. From the diagram, I hope you realize these are the pair. Hopefully you all didn't see these two. No, it's AB and DC. With these two pair of parallel lines, to find BCD, what can I find then? Okay, take a close look. I know you guys are a bit shy. So in this case, just take a close look, think about it. Okay, linking to the properties where you have parallel lines. Take note, you have your Z, F. When you have parallel lines, remember these three. These three will continue to haunt you. When you have parallel lines, these three will continue to haunt you. Z, F, C. What is Z? Alternate. What is F? Corresponding. What is C? Interior. Okay, if you take a close look here, if I want to find BDC, what other angle will help me find it better? Okay, I think I see some labeling. Very nice. So, if I were to find this, which I think you are relating to this, alternate angles, in this case, ABD, what can I say is, what's the relation with ABD and BCD? Okay, they are equal, very nice. They are equal, very good. Okay, so your final goal in this case, instead of looking at this super weird looking triangle, I can just use, actually in this case, I can use sine rule. Work with this triangle because you want to find this. You have all three sides. Actually, for this case, you have the free usage. You want to use cosine rule, up to you. But in this case over here, I am working with sine rule. Okay, because previously I was cosine rule already. Okay, but doesn't matter. So let's say I'm working with sine of ABD. This is over 1.2. Right, this is equals to, working with your previous values, sine 150 degrees over 20299. Bring your 1.2 over. Okay, all right, just key in your calculator. I'll key in together with you all. You're going to get a string of numbers, but just write it down to 5 to 6 significant figures. After that, you take your sine inverse. Okay. Give me a moment. One. Okay, you are going to get this particular angle. Okay, but take note, this is not your final answer. We want to find BCD. From your diagram, we know they are related, so we need to write this down. BCD equals to ABD. And in terms of alternate angles, because of the parallel lines, we must write the reasoning down. 17.19237, you have 17.2. Okay, so this is the working I have for B, but I understand that there are multiple approaches. So anybody want to actually check whether your approach is okay? As long as you get the same answer, it should be fine. But if you are afraid of the process, just raise your hand. I'll go over to you and I can check for you. I know some of you may be ahead. Anybody? Can Okay, make sure I understand. Which part you need to check? Okay, Oh, sure. Okay, now all good. Anybody needs to check something? Not sure? Okay, if you are wondering, yes. Bearings in the intermediate answer or as in the bearings? Wrong. 1 dp. Make sure you do 1 dp. Bearings are angles, so make sure you do 1 dp. Okay, if you are talking about part C. Okay, any questions for part B? Any approaches? Can Okay, I know some of you are ahead, so let's go to part C. D from B. So check D from B. What is the angle we are calculating? Go to the part D from B. It's just this angle, right? How do we calculate? Just now it was mentioned, this is 90 degrees because due west. If you know your compass, north, south, east, west, this part here is 90 degrees. Okay, north, south, east, west. This part is 90. North to south, south to north, south, east, west. All these parts are 90. Okay, so if you work with this, you realize all we need to do, angles at a point. This is your whole angle. I know this is 90. I just need to know this angle, which we have found in part B. So, your whole working, just check, it will craft out to this. When you are using the values, please use the intermediate ones. Bearing of D from B, in this case, it will be 360 degrees minus 90 minus this specific angle here. Okay, you will get a string of numbers, but just make sure you are rounding to 1 dp for your angles. Okay, if you use this one, there is a reasoning I need to write. Don't miss it. Any geometrical reasonings, I want you all to start having a habit. Write it down. Angles at a point. And any parts not sure, please let me know. Sorry. Okay, can, all good. Still can follow. Okay, hopefully it's just refresher. Now, this one. I don't want you all to do mental imagery. I know the mental imagery is useful for exam prep, but not for this. Why? You don't want to picture yourself in the different triangles. What I want you to do, note this, standing at town B, please identify my different stuff first. Town B. Town B is here. Okay, a tower is standing here. Okay, along the path CD. Now, you tell ourselves, along the path CD to achieve the greatest angle of elevation, again, I need the shortest distance, which is this one, related 90 degrees. Hard to see, my diagram a bit messy, starting to get a bit laser. Draw it out. So just now, I need to find the shortest distance first. Draw. Label, this is D. This is your angle. Draw it out. Okay, D is just an alphabet I'm using, but if you want to use A, you want to use B, you want to use whatever, the 26 alphabets, you choose one yourself, up to you. Okay, I'm not going to take any preference from there. The angle we have found, if you refer to the diagram, okay, let me just scroll up a bit, sorry. This is the shortest distance, this is the angle, which is BDC. Okay, we have found it here. This angle will be here. Seven. Yep, here. Okay, if you write 23237, doesn't matter. It's just an intermediate value I need to consider. Tell ourselves, what is the goal? This is a right angle. I'm finding this one. You have an angle. You want to find the opposite. You have the hypotenuse. So tell yourself which one. Okay, as you write down, I want you to picture the image that I've drawn and make sure it makes sense. Any parts of my working that does not make sense or seems alien language to you all, please raise your hand and ask. Any questions I'll entertain as long as it's related to the content. Okay, the values you realize I'm not mouthing because it's really calculated work. My focus is on the process. Okay, greatest angle of elevation is 18. A bit different, find the height, but the concept stays. In this different one, I already know the greatest angle, but it's okay. Draw the diagram again. Okay, in this case, I backtrack to the diagram I have. Shortest distance is here. Your tower is standing at B. You are looking up. Okay, hard to see, but you realize is this very thin looking triangle here. Again, over here, you are looking up. It's been blocked by the north line, but there is this shortest distance. You are looking up to give you your particular angle of elevation. If you draw it this way, I tell you hard to see. Draw it in a different dimension. From here. Okay, sorry, wrong question. From here, I'm going to draw in orange, just check. Oh my God, sorry, my art a bit failed. Oh my God. Okay, I am looking up. My shortest distance is here. I am finding the height. Okay, take note. My 0.599 is this particular distance here. I'm just inputting this here. Okay, after that, you apply your trigo and then you resolve. Okay, any questions at this point? Okay, at this point, just ask. Really, any questions, I am okay one. Just ask. Okay, this is tangent, cos opposite, adjacent. So apply. Okay, key in accordingly, but take note, this one, your units are in km. They want in meters. So just convert accordingly lah. Multiply by 1000 in this scenario. Answer 195 meters. Okay, any questions for this particular long style here? Can? All good? Can Okay, I have one question here. How I get the orange triangle? No problem. Okay, so from here, the pink triangle is my shortest distance. Take note, my shortest distance here is this one. If you refer to the question, I am looking up. You have your shortest distance here, you are looking up. This part where I have drawn, okay, I'm going to scroll down, is I'm over here, I'm looking up, shortest distance with my height. This is your angle of elevation to look up where you have your T. Okay, Levine, is this clear now? Okay, any questions on the floor here? Free to ask, Okay. If all is good, 2 more variants to go. All right. Now, this one, I believe you all can answer this very straight. Once you see this, everything is given. I think 20 seconds, you all can get this down. Find the length area of the part ABC. This is a triangle. Area of triangle. Why I say 20 seconds? Because everything is given there. We call area of triangle, I need 2 lengths. I need the angle that is sandwiched between the 2 lengths. Do I have them all? Yes. Can I apply straight? Definitely. Okay. You're going to have a very big value, but it's okay. This will be round off to 3SF. Okay, this is just the area. Okay, can? Okay, look at it's just the application of a not right angle, a triangle. Okay, straight application. All good? Can Part B. It looks like another one with a lot of steps, but you realize 1 mark. Why is it 1 mark? H hovering above B. Angle of depression of A from H. Take note, now is depression. What's the depression part? Okay, not saying you're having depression, but what is the depressed part? B, helicopter is hovering, angle of depression is this way. I'm looking down, or in fact, the helicopter is looking down. So, hard to see in the angle, draw it out. Above B, helicopter H is hovering above B. Angle of depression of A from H is 40 degrees. And then we take note is vertical, this is 90. You have everything. AB, if you refer to the diagram, this is given. You are finding this part. Now you may wonder how we can get the H without anything. Take note, this is angles of depression. You can apply alternate angles because we are forming your line of sight. It's always vertical first, not vertical. Horizontal first, then you look down. So in this case, by alternate angles, we know this particular angle will be 40 degrees. Okay, reasoning, we need to state alternate angles. We are not so sure what the parallel lines are, but we know they are parallel lines. Must write, just write parallel lines, even though the parallel lines, the alphabets are not stated. After that, we then know this is 40 degrees. Therefore, tangent 40 degrees, this is equals to h over 240 key this in, punch in your values, write these numbers down. You are right on track. Okay, so you realize over here, I drew a lot of triangles. For this particular topic, I urge you to do so because it is really quite visually, I would say, heavy. Okay, and make sure you draw and understand accordingly. Okay, all good. Any questions? Okay, usually my convention is, I understand math can be quite daunting. 3 hours is long. So what happens? Over here, we take a quick 5-minute break. So for those who need to wash your face, go ahead. We resume at 7:41. Okay? All right, online side, if you need to resume, if you need a short break, 7:01. Also, for these 5 minutes, if you have any questions, feel free to ask me. Yeah? Okay, if you all have any questions, please ask me. Yeah?
Very short, but yeah, that's right. Wait, I'm not gonna. But I'm pretty sure my step okay. Oh, maybe you say. My grandmother was like and guess what? This class have fucking the kid did. Now my whole room smells like home you. She could wait, could it put your she was straight the whole glass and she fell the time.
Yeah, so you tell yourself how to check the numbers. What kind of mindset is that?
It's quite popular.
All right, let's come back, push on a little. Okay, you guys are a bit excited. I think I'll be excited on quadratic and polynomials. We're going to reach there soon. Okay, give you a while to calm down before we start. Okay, no worries, no worries. Okay, anyway, I say again, if I know you all take the effort to come down, okay, if you are hungry, you all need to eat, I'm okay. Just don't make sure you all treat suddenly, I turn around, I see one platter of steak on the table or what's not, just eat and make sure it's clean. Okay, can? All right, last question over here before finally algebra. This is your last trigo part before we move on to algebra galore. Okay, now, this one over here. Same style. All right, calculate the bearings of D from B. So in this case, take note, what you are calculating is this. Okay, but tell yourself in this case, what are the angles you have? Okay, and in this case, specifically over here, I saw some of you as I was walking around, you actually wrote it down, which is good. B from A, we know this is 151. Okay, and then we also know, in this case, D from A, this is actually 237. Okay, so we write all these down first. Now, ultimately, let's check what is an angle that will help us find. Okay, we backtrack. Okay, in this case over here, I want to find this one. Because if I can find this one, the rest is history. Okay? Because I can use angles at a point to find this particular blue angle here. So how do I find? First up, we are not sure of every stuff. So what happens? We make use of, in this case, what we have. So 237, 151. This is, hush down a little. Thank you. All right. Take the subtraction, BAD. Okay, we can find this angle first. Wait. D from B. My apologies. I have found the wrong angle. Okay, let me backtrack a little. So sorry. The angle that I'm finding is not the one that I've drawn just now. So I emphasize that the angle I'm finding is in red. Okay, I made a mistake there. My apologies. Let me withdraw a little. Okay, the bearings are still correct. This is 151. All right, this one is 237. But the angle of bearing of D from B, okay, is this angle. My north line is still straight. D from B is this angle. Okay, so sorry, I'm finding that angle. It's the angle at the bottom. Okay, so please rectify your diagrams accordingly if needed. And the ones in pink and orange are the ones that are stated in the question. Now check, yeah? The process of finding BAD is still required. 237 minus 151. Why does my wording look like it came off a horror show? Let me rewrite. Okay, 151, this is equals to 86. And in this case, this 86 is here. Okay, now ask ourselves, which angles will I need to find my bearings here? If you realize, I can make use of angles at a point again. If I know this angle, if I further know this angle in green, all will be good, right? In this case, if I know angle ABD and my angle here, all will be good, right? How do I find? We settle the one with north lines. North lines are the ones that are parallel, right? Parallel lines, we call, you have your ZFC. I know the orange one is 151. All is left is to find the angle in green. This is in a triangle. So in a triangle, we know we can make use of either sine rule or cosine rule. Take a close look. I know this is 86. Okay, I want to find, in this case, ABD. How would I do so? I don't have one more side to help me find the angle. So sine rule will work for this scenario. Sine ABD over 163 equals to over 329. Oh my God. Once with this, you realize I can just manipulate my values over, which is sine ABD equals to, just bringing it over 163 sine of 86, 329. Okay, bring your sine inverse over. I'm just working ABD as, take the sine inverse, 29619. Okay, this is my green color angle here. With this one, let's check. I have 151. Okay, I want to find this angle. Take note, I can actually do it in one step. Finalizing angles at the point, bearings of D from B. This is 360 minus my particular angle here. Minus my, this one I'll write down. Okay, I will need you all to check whether there's any queries on your side on how I get 180 minus 151. Okay, 180 minus 151 comes from the green color part that I've just drawn, my C. Okay, interior angles are. Once I've written this down, subtracting every single thing there. Okay, I get 301, 38076, round to 1 dp. Okay, bearings, remember I need to fulfill both 3 digits, 1 dp. Okay, can all good? Okay, for those who are ahead, please check your workings as well. If it's a bit different, please let me know. Yeah, I'm just rewriting my stuff. Okay, please check your workings. This is my interior angles. Okay, can all good? Okay, as you write down, I want you all to check the thought process behind. Okay, let me move on further down. You also need to write, need to check. And any questions with the workings? Okay, now calculate the distance from B to C. Check, where is it? B to C is my particular distance here. We are working with this triangle, same stuff. Tell yourself, okay, sine rule or cosine rule. Understand some of you are working ahead already. If you look at this specifically for this particular triangle, D to C. Tell yourself what is given. Okay, I have two sides, one angle. See which one fits into the formula. Take a close look, stare at it nicely. All right, take note. I'm finding this one. I have the angle that's opposite and it been sandwiched. So in this case, this will be your cosine rule. So BC squared. So working with it where you have two sides that are sandwiched. 152 square plus 329 square minus BC cosine of A. This is what I have here. After that, simply take the square root and you are done. Okay, take the square root, all right, you get 253.813. Take your calculator, press, you have 254. Okay, straightforward cosine rule. All right, just take note of the sides and angles in this case to repeat to help you find. And see some knots, all good. Okay, last one. Aircraft flying above D. For those who are ahead, picture yourselves. All right, try to draw my triangles. Flying above D, we check. Okay, where is my D? It's flying here. When find the aircraft from C, when it is 245 above D. You are finding the angle of elevation. So above D, it's flying above here. 245. You want to find elevation. Even better, this side is given. But if you draw like just now, how I draw like this, it's going to get confusing. Again, emphasize. Here got a lot of space, right? Draw my triangle lah. Oh. H, 245, D and C with my angle 152. Theta, you can use any alphabet, but I love to use theta because it signifies just the angle lah. Okay, you want to use A, B, C for the angles, up to you. Okay, so I have tangent theta equals to 245 over 152. This is just the manipulation. Bring the tangent inverse over. Okay, take your calculator and press 58.18419, 582. Okay, so moral of the story for such questions is not really taking note of the working process angle of elevation. I'm not so concerned. Is when you are not able to see the diagram in a different manner. Like just now, if I were to visualize in that direction, where I try to force my angle of elevation this way, I assure you, you will get more confused. Draw it in a side point view, POV. This way, definitely easier for you to see. Because when you visualize triangles, it has always been this POV all the while. Okay, any questions? All right, if all is good, all right, this is the trigo part, and I understand you all have more to trigo. Okay, so this part is without the ASTC. If later after this part, you got some questions for ASTC, feel free to ask me. Okay, I'll try to answer as much as I can. Okay, now next one. I hear some sighs. I don't know whether it's a sigh of relief or sigh of stress, because the next one I'm going to go through is polynomials part. And when it comes to polynomials, the first thing they will test is this one, remainder and factor theorem. What are they about? Yeah. Okay, can see a lot of chatting there, no worries. Okay, so in this case, in terms of polynomials, these two will be one thing that they will do for you. Remainder and factor theorem. Now, essentially what it tells you is this. Long sentence, very hard to read, right? Basically, it tells you this. You want to find the remainder, you look at the factor, you look at which value makes it 0. In this case, a minus a is 0. Sub this value in, that's your remainder. Example, I have that polynomial. I want to find the remainder. What makes this particular divisor 0? 4. You sub 4 inside, that's your remainder. That's it. Okay, don't want to emphasize too much on this part as well. Because x equals to 4, just in case if your brain stuck, 4 minus 4, 0. That's why 4 goes into all these things here. Okay, this is the remainder. As a result, 4-factor theorem. I have a question here. Give me a moment. As a result, for this particular concept here, if I talk about being a factor, okay, example, if we bring down to numbers, 2 is a factor of 6. Okay, yeah, 2 is a factor of 6. 4 is a factor of 8. That means if you take 6 divided by 2, your remainder is 4. Same thing here. As a result, if I sub in the number, in this case, my number x is equals to a, my remainder is 0. And this will be very prominent, I assure you, very prominent in your polynomials question. Very prominent. Okay, they will ask you, in this case, show that it's a factor. After that, you need to factorize. Okay, what do I mean? Okay, let's go through the first part here. Simple question. Okay, not simple, straightforward question, I would say. Okay, first part. They will ask you to factorize this polynomial. But first, finding A's and B's using these particular statements. Has a factor, leave a remainder. How to know how many equations to form? Tell yourself this. You got 2 variables. How many equations you need? 2. Where to form these 2 equations? 2 variables. You need 2 equations. Therefore, 2 information. Which is why I actually highlighted over there for you guys. First one, factor of x plus 1, literally stated here. Rest of it, substituting x plus 1, that's your first equation. Second one, leaves a remainder. Sorry for that. Can you help me change? This should be negative 24. Sub it in, that is what you should have. So depending on how you want to solve. Over here, I did the elimination method 1 minus 2. This elimination, take note when I do 1 minus 2. 1, 2. So when I take 1 minus 2 is this one minus this part. Rest of it is really sub and solve accordingly to get your constant. Okay, any parts not sure on this particular explanation or how or why the workings are as such? Please ask. Yeah. Anything not sure, ask. Yeah. Okay, as a result. Okay, if you take a close look, there are 2 methods. Okay. Factorize and write down solutions. This is your typical question for polynomials when you mix it with remainder and factor theorem. You know one of the factors, and in this case, you will need to break it up. Okay? Just to check, how many of you all actually do long diff here? Or you remember what's long diff? How many of you all actually prefer, in this case, 2 methods? How many of you all actually do more of method 1 here? 1? Good, good. More of method 1? Long diff, okay. So in this case, long diff, let's just recap how we do. Okay, so maybe after this session, I'll actually convince you that method 2 will be better. Why? Okay, for the last question. Don't worry. Long division, let's recap. x cubed minus x squared minus 5x minus 3. I know x plus 1 is a factor. So when you do long division, tell yourself and remind yourself, okay, you are essentially slowly getting rid of all this bit by bit. First, x cubed. What should I multiply to x plus 1 to give me x cubed? To get rid of x cubed? Okay. X squared lah. So I have x cubed plus x squared. Subtracting this, remainder is here. Next, I need to get rid of negative 2x squared. Again, same notion, I multiply by negative 2x. Okay, negative 2x squared minus 2x, subtract. I need to get rid of negative 3x next. So you realize as you write down the terms, the other one all goes down. Negative 3. And this is what you get. Okay, so all in all, what we are doing, we are multiplying each of these things to get rid this term first. Whatever comes after, all right? Whatever comes after, okay, is what we will consider in your next few particular subtractions after you do a long division. Okay, but for me personally, as much as I went through this method one, I personally, for myself, I don't like this method. Why? For me, you realize if let's say somehow there are a lot of steps that get prone to mistakes for this one. One, your subtract, you forget to put this negative sign, you suddenly get 0. Okay, 2, you miss out one constant, second step haywire, everything goes haywire. So for me, I will actually prefer this one. Okay, if you take a look at this, for me, you all don't have to asterisk this. Okay, for me, I personally prefer this. Why? Okay, over here, let me just do a quick convincing for you first before I continue to convince you further. But ultimately, up to you. I'm not going to force. If you look at this one, okay, you may wonder how I get this slowly. Left-hand side is this polynomial. I know for a fact that x plus 1 is a factor. Definitely, it said that. Now, over here, you may realize, if I have a cubic, I divide by a linear factor. This side must be a quadratic, right? The main issue is quadratic. Ax squared plus bx plus c. I don't know my a, I don't know my b, I don't know my c. Then you say, why is this a better method? In fact, if you actually stare at this polynomial with this linear factor, you can get you can actually get two things free already. Why? Over here, x cubed, right? I have x. If I want to get x cubed, what must multiply to x? X squared, right? One free term here. You look at the constant at the end. Negative 3. I have a 1, right? What must you multiply to 1 to give me negative 3? The only thing you actually don't know is the middle. But no harm. Why? I can just compare, in this case, one of those terms here. Doesn't matter whether it's x squared term, doesn't matter whether it's x term. Just choose one of them. My mood today, I want to choose negative 5. So ask yourself, what is the possible combination for me to get my x term? And all in all, when you look at this, you already get two free things. The harder part is to solve a linear equation. That's it. Okay, maybe that is not really a good convincing. As I go on, I hope it will be better lah. Okay, but in a way, I prefer this because all in all, it boils down to solving a linear equation, which is much simpler, I feel, as compared to Yeah, you forget to put a negative sign. Oh my God, I forgot to multiply by 2 here. A lot of things can happen. Okay, can so again, I leave it up to you to see which one you all want to choose. I'm not gonna force here. Okay, now, when it comes to polynomial questions, I know you'll be like, wow, very, very tedious. Okay, but as long as you follow the flow accordingly, all right, it will make your life easier. You have this polynomial, factor of x minus 1. Okay, you have two info, find the values of P and Q. Take note, okay, my light blue one gives me 1, my orange one gives me another. Tell yourself, what value do I sub to get me, in this case, what value do I sub, and as a result, what's the end result I get? Okay, factor of x minus 1. So that means if I actually sub, it gives me 0, right? First, you no need to label because it's given already. I know substituting 1, it gives me 0. So from here, you will work towards it. Okay, just work it out. You have 4 plus q minus 3 plus 1. This gives me 0. Manipulating your way through. This is achieved from your blue color statement. Okay, it's a factor. Next one, leave a remainder. Okay, for those who are ahead, please check. For those who are following, it's okay. Check. F of negative 2. When you sub in, it gives you 33. Right now, you have found a value of Q. So please take note that value of Q is brought in. So I have 4 of negative 2 P. You may wonder why got power there one. It's okay. Just solve as per norm. Don't get scared. Minus 2 negative 2 square minus 3 negative 2 plus 1 equals to negative 33. This one looks very daunting. Leave it alone first. We have 4 of negative 2p minus, okay, this gives me minus 8 plus 6 plus 1. From here is my normal solving. 4 negative 2p. This is give me a moment. Okay. And it seems to. So from here is just a normal solving. Your right hand side will be a 32 with a negative. Okay, divide by 4, you realize you have this. Now, tendency, please check. I know for you all, when you want to solve for exponents, you all want to log or log. But for this case, take note, log or log doesn't work. Why? Negative value. So for this one, okay, if they were to give you this scenario, just tell yourself, 2 to the power of what gives me negative 8. Compare. Done. Okay, so don't key in calculator. Okay, let's try log of negative 8 over, in this case, log of negative 2. Okay, I assure you, you will get math error or log. Okay, don't try negative. I tried it myself just in case. Okay, so if you see negative numbers, it's a sign. Don't do logarithms. You can. Now, with these values here, I have Q equals to negative 2. P is equals to 3. Look at the next question, typical one. Using your values of P and Q, solve. And in this case over here, you realize I have a particular factor that is formed. Okay, let me refer. So I have fx. So sometimes if you're not sure, copy and paste your equation down for x3. Okay. So I have 4x3 plus, in this case minus, sorry, minus 2x squared minus 3x plus 1. Okay, we are solving this. Take note, when you want to solve, tell yourself first, where is my factor? Question will usually say. Otherwise, if never say, we can find from our calculator. Okay, go to menu 5, polynomial 3. Press in the coefficients, dig out a particular factor from there, then you solve. Okay, if you need help for the calculator entries, let me know again. But for this one, we know it's a factor of x minus 1. So what can we do here? 4x cubed minus 2x squared minus 3x plus 1. This has a factor of x minus 1. You can do long diff, okay? Let's try. But I want to see by the end of this revision whether I can convince you with this method. Okay? Anybody tell me what is this term here that I should have? I want 4x cubed. This is x. This term here should be y squared. Copy, paste. Constant. I have 1. I have minus 1. What will be the term here? Minus 1. The hardest part of this method is... the hardest part of this method is to find my b. In this case, how hard? You choose lor. Either you want this or this. You want to compare which one? Up to you. Your choice. Really is your choice. Compare, in this case. Let's say I compare, just now my example, I compare what? Just now I compare x term. Okay, now I compare x squared term. Left hand side is negative 2. Right hand side, tell yourself. The x multiply to where to give me x squared? The negative 1 multiply by where to give me x squared? I have 1 times b plus negative 1 times 4. This is the hardest part if you were to do compare coefficients. And from here, you realize my polynomial really simplifies to, if I want to solve this, okay, I have x minus 1 for x squared plus 2x minus 1. Okay, now the hard part for this is, they say non-integer roots in third form. So that means, when you are solving this, you cannot just press calculator. This tells you this. This is equals to 0 or this is equals to 0. What's the best way to get my cert? Recall your quadratic formula. Negative b plus minus square root over b square minus 4ac over 2a. Okay, break it up. You have negative 2 plus minus this one over here. Evaluate my cert. This is going to be 4 minus 4. This is 20. Okay, simplify a little bit more into their simpler cert form. Okay, we know my 20, I can break it up. Let me do step by step. Root 4, root 5. I can break up my certs this way. Okay, even though I'm not revising certs here, this should be embedded. Negative 2 plus minus 2 root 5. Okay, my 20, I can break it up this way. After that, 1 plus root 5 over 4. because I'm expressing my roots, and the other way around. Okay? So over here, my focus is not on the quadratic formula, but my main focus over here is more for the comparing part. Hopefully, I can convince you all that this is an easier method you all can go for. Okay? Right, take some time to look at this. Let me know if there are any questions. Okay, can Okay, any questions down the floor, or if your answer is a little bit weird, any steps you're not clear, please let me know. Okay, all good, Okay. Okay, you are solving, so you no need to put in brackets. Just leave it like that. Yeah. So next one. When it comes to polynomials, it is always going to be these few conventions. Okay? Over here, same stuff. Find A and B, two equations, two variables, two info. The two info is this way and this way. Okay, exactly divisible by 1. Maybe time to sabo some of you all to help me answer. I'll be tired of talking already. Exactly divisible by x minus 1. What's the value I should sub so that, and the value I get? Come. What's the value I sub, and what will the value I get? Yeah, yes. 1. Okay, what's the value again in the end? F of 1 exactly divisible, ending is 0. Are you still looking? Is 0 exactly divisible? Yes. Okay, so sub it in. You are going to have A. Okay, A of 1 cube minus 2A plus B 1 square plus 2 plus B equals to 0. So over here, you realize what I'm essentially doing. It's I am forming an equation to solve. So check. This will give me A minus 2A is negative A plus 2 equals to 0. Okay, this is the A that you will get lah. Okay, so in this case, if my first equation here gives me 0, the second one will definitely give me something. Now I'll give it a try, maybe someone on my left, right? Okay, I kind of forget the names here. Sorry for that. Okay, let me just arrow here. Okay. Caris, can you tell me for the third one, what value do I sub to get me the green one? Just the green one. Yeah, I'm just looking from the list. I'm not subbing anything. Sorry? What value do I sub? This is a bit tricky, not worry. Tell yourself, what value you sub will get you 0. It looks tricky, but it is what it is, you think. Okay, big picture. What value you sub here will get you 0. What value you sub here will get you 0. This is value. You see, 1 because 1 minus 1 is 0, right? You want to make sure this is 0. You want to make sure this is 0. Don't worry, this is a tricky one. You want to make sure this is 0. What value you sub will get you 0. It is that value. You say again? 0 lah. That's it. So f of 0 will give you? Yeah. So this is a tricky one because when you see x, we all stun. What value to sub? Ultimately, the value here you are substituting is to ensure you get 0, ma? Same concept over here. To get 0, I want this to be 0. To get 0, I want this to be 0. Can so therefore f of 0 is 3. In this case, I have, let me zoom out. A of 0's cube minus 2 with 0, 0, 0. Okay, never mind. You know what? This actually just gives me b is equals to 3. Okay, because this is 0, this is 0, this is 0. Okay, if you wonder why this is 3e, okay, let me do the exact steps. I am doing this. Okay. Okay, this is how I get my 3. Okay, so this is a substitution involved to get 3. For those who are wondering, how come I can jump to 3? Okay, if you all can see straight, good. If you all cannot, additional step, it's fine. No harm. Okay, can Part B, factorize fx completely. Haven't we done this in the... Haven't we just done this? You realize we have A, we have B. Okay, let me just rewind a little. A is 2, B is 3. So this is 2. This is 2. This is 3. I'm just labeling the value so that it's easier for me, yeah? So 2x3 to 7. Okay, so my polynomial, these values are just for indication of what's your A, what's your B, yeah? Ultimately, just sub them in. Okay, firstly, fx is 2x cubed minus 7x squared plus 2x plus 3. This is what you need to factorize out. Okay, you're not solving, you're factorizing. Check from the question. Which one is your factor? Your factor is not x, definitely not x. Exactly divisible by x minus 1. Again, I'm going to convince you the second time out of the n times I'm going to do today. X minus 1. I have a quadratic. What is this term here? I have 2x cubed. I got x. So what is multiplied there? Three x minus 1. What is the term here? What's the hardest part to solve this? I choose x term maybe. You want to choose x squared term? Up to you. Your choice. 2 is on the left. The other one, x to minus 3. So I minus 3 times x. The other one is minus 1 to... Wait, 2x squared, sorry. Minus 1 to this way. Okay, 2 in this case minus 3 minus 1. Solve it along the way. You get b is equals to minus 1. Okay. Therefore, your polynomial will just be 2x squared minus x minus 3. Okay, they say factorize completely, so please check whether this can be factorized completely by just keying the required numbers. Okay, one way to check, this one, I know you all will use what method? Multiplication frame, right? Take note, no need. Calculator can do the work for you. 好，equate this to the calculator, it will give you two roots. Okay, let's say I'm equating and solving. You have x is equals to 3 over 2. X is equals to minus 1. In case you are wondering what you are doing when you're keying your calculator, before you solve this, you are doing this. One more step before you're solving, you are doing this. Once you reverse engineer, you realize these two are your factors. These two are factors. Done. . That's it. So this one, you can work from the factors that you can get and you backtrack. This is a hack that you can do. No need multiplication free. I'm not saying I teach you all bad things, but really time is of the essence, so shortcuts are the best. This is what happens when you key in your calculator, you get these two values. You reverse engineer, it's really saying this is equals to 0, this is equals to 0. The one that I've highlighted are your factors. That's it.
Mr. Jason.
Okay, any questions?
Mr. Jason.
Sorry, which one?
We got negative.
Wait, let me check. No worries, just let me check, don't worry. A is 2. Yes, so sorry. Thank you for verifying. This is minus 5, yes. Thank you for verifying, yes. Okay, let me check whether my answer still holds. Okay, yes, it still is factorizable, so sorry. Yeah, so it's minus 5. Thank you for verifying for me. Please check. Okay, but the answer still holds. Okay, in this case, I have 2x plus 1 as my factor, and the other one is x minus 3. Same concept still holds where I have x is minus half, or x is equals to 3. Okay, you work backwards, essentially telling you x minus 3 is a factor, or 2x is equals to minus 1, 2x plus 1. And okay, let me move on since most of you are just staring, means you all understand roughly. Now, hence or factorize. Now, when you see hence or otherwise, okay, please take note, use the hence part. Don't can go and otherwise. If you take a look at this type of question is always related to the previous polynomial. So in case if you are not sure what your previous polynomial is, okay, I'm going to do some magic here. Give me a moment. Okay, let me see how I can do this. Okay, let me erase all this. Okay, this is your previous polynomial. Okay, we are going to compare. This is the previous polynomial you are working with. And this is the one we are working with now. Check. They will usually be similar but different. What is the main thing that's different here? Okay, let me arrow someone. La 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 la. Okay, let me see. Nicole, would you like to try? What is something that is a bit different here? This is my new one. This is the one that I need to work with. Okay, so you realize the thing is the same, very good, but the x is x minus 2. What does it mean? If you actually treat this thing as like the x itself, your steps to solving will be the same, right? When you're factorizing, when you're simplifying, you will get okay, this is for your f of x, you will get this one here. Just that right now, okay, this is the x you are dealing with. So when they say hence, we are really just making sure, okay, this is now the x. How do we make use of the similarity? Same but different. And sub this in. That's it. Please do not solve my polynomial again. You are not supposed to solve it or factorize it from scratch. Don't solve from scratch. Okay, take note, this is the x, because if you treat this as one thing, if you factorize, you will get the same result as the top. Right now, I am using the hence part. That's it. So don't solve from scratch. I know they say otherwise, may want to say, teacher, I don't know, I want to do otherwise. If you realize you do the otherwise, means you need to expand this, find my own polynomial, don't do that. Okay, very tedious already. Life very tedious already. Don't make it more hard on yourself. Okay, any questions? Not sure, please ask, yeah? Okay. Next few questions is going to be the same trend. Last part is going to be the one where I relate it to the previous question, the previous polynomial you have. Okay, I think at this point, you all will be quite familiar with these terms already. Find P and Q, you need two info, two equations, two variables. Okay, factor of x plus 3. Remainder when it's 24. What are the values to sub? Okay, this one over here, one thing to take note. Okay, I will define this as my fx. Okay, if you don't define this, some of your schools may mark it down. So we define it so that we can, yes, sorry. Yeah, go, do it. Yes. Okay, so if you actually don't write and define your f of x, some schools may mark it down. So you define it accordingly. Anyway, I want to go to toilet, just raise your hand. Okay, one. Okay? If you define it accordingly, okay, it's easier for you to write. Okay, and also mentioning some schools will mark you down. From here. So yeah. F of minus 3. Sub it in, we have. Just sub in as per norm lah. So you'll get a pair of simultaneous equations that you'll need to solve. First one is this info. Okay, this is negative 27 P plus 9Q. Okay. 29 times 3 plus 87 minus 6. Okay, so bring everything over. This tells me P plus 9Q is equals to negative 54. Okay, really having two info, making use of the first one first. Okay, second one a bit too dark. Let me shift it. Let me make it brighter. Okay? Okay, next one. Divided by x minus 1 gives me a remainder of negative 24. So sub it in and you will get a value of negative 24, which is P plus Q minus 29 minus 6 is equals to negative 24. So if you have this, you bring everything over. Okay, this will give you 11. Two equations, two variables. I'll give you the liberty of choice to choose what method you want to do. Okay, so some of you all may prefer substitution. Some of you all may prefer elimination. Personally, for me, I will do elimination where I will have 1 minus 2. This is negative 54 minus 11. Okay, from here, wait, let me see.
I think I thought 81 minus 27 instead of like divided by
Wait,
27.
ah.
Are you hearing? Yeah.
Oh, give me a moment. Yes, thank you for reminding me. Okay, there should be a 27 there. Yes, I missed out 27. Thank you very much. Okay, let me rewind. Okay, so in this case, thank you for reminding me, being my sharp eye. So over here, P is 11 minus Q. I'll actually do up a substitution method instead. Okay, Lavish, yes, that's good. Wait, let me check. Wait, Choto. Wait. Wait, sorry, let me check. Wait. Okay, correct. As a result, this one will be... Yeah. Sorry, I don't think have already. Yeah. Okay, thank you. Clear? Okay, let me check. Okay, I better check. Okay, -3, -27, 9, 87, minus 6. Okay. Yes. Okay, all looks good for me. Yep. You... I didn't realize after I substantiate. Yeah, you can do that also. Thank you very much for your suggestions. Keep it coming. Okay. So I have -3 plus Q equals to -9. Okay, let this be equation 1. Okay. I can still do elimination. Never mind. Let's proceed with substitution since I already at there. Right. Anyway, thank you for looking out. Okay, I appreciate that. So in this case, sub 3 into 1. Okay, you can do elimination. It's okay. It's fine. Okay, but if I were to sub, so I have P is 11 minus Q plus Q equals to -9. This is -33 plus 3Q plus Q equals to -9. Okay, you're going to have 4Q is equals to 24. Q is equals to 6. So your normal solving, therefore P is equals to 11 minus 6, which is 5 lah. Okay, so again, really using the info, I don't want to spare too much. But more and all, making use of the info to get 2 equations and to solve. Okay, so I know these kind of questions are quite tedious, but as it comes along, as you write it down, your values of P and Q, making use of the info is really quite standard at this point.
I'm pretty sure it's 11.
All time already, hanging there. Any questions up to this point? I think it's quite mechanical at this point. Okay, just hang in there. Using your values of P and Q. Okay, P and Q. P is 5, Q is 6. Okay, P is 5. Q is... Okay, this should be... Q is... Wait, give me a moment. So sorry, Give me a moment. P is 5. This should be 6. Hang on, guys. So sorry for that. 29, 8. Wait, give me a moment. Yes, I know there's a 9 there. Just give me a moment. Let me check through. Hold up. 29 minus 6. 24. 11 minus Q. Okay, just put my Q here lah. Okay, it will be a typo. Just put a Q here first. Okay, rectify along the way. But the idea is this: making use of these 2 values, put it in and solve accordingly. Okay, it's just it will be just a typo there. My apologies. So our polynomial in this case 5 and 6. This is the polynomial we have, so we sub it in. Okay, minus 29x minus 6. Okay, we are solving and the standard step comes lah. First up, our factor is x plus 3. So what happens? We want to solve and break our fx. Okay, in this case, breaking our fx, sorry for that. Copy and paste the polynomial. Breaking it up, knowing is x plus 3. Again, I'm going to advocate my method. Yes. Okay, first one. This method here, first one, I have 5x squared. X, 5x squared. Any issues? Okay, seems like there's some checking over there. Any issues here? No, Okay, next one, the other term. Negative 6 plus 3. I have negative 2. As a result, the only thing I need to solve is my bx term. Okay, solving it accordingly. All right, I need to find my b. What is my b? Depending on what you compare. Let's say I compare my x term. Negative 29. This is equals to either you expand it this way or you expand it this way. Okay, so therefore my green color arrow tells me negative 2 and 3b. 3b gives me negative 27, b gives me negative 9. So therefore, breaking up my polynomial, I have this. Okay, solve the equation, just check, okay. From the polynomial that we have, 5 minus 9 minus 2. Okay, it's factorizable, so we can break it up even further. So I have 5x from your calculator head, x minus 2. Okay, sorry for the technical issue just now, but I hope all is resolved. Technical issue meaning my brain. Okay, so from here, if I'm solving this, I'm equating this to 0. From the roots here, it's just x is equals to minus 3. Okay, I have x is equals to negative 1.5. 1 over 5, x is equals to 2. Okay. Sorry for the confusion just now. So I'm going to finalize this first. Let me know if there are any queries down the floor. Any questions here? Feel free to ask now. Like any part where you got confused in the values here, please let me know. Can all good? Can? Last part, when you see the word hence, take note. How is it related to the previous polynomial? Okay, comparing this and now this one here. Okay, take a close look. What is the main difference between this polynomial and this one that I have? So I know some of you are a bit stuck here, so let's explore together. This is the one from the question. This is the one from the question, but they want you to solve this. Maybe I rearrange it a little better. Okay, if I rearrange. It's this way, right? I am solving this instead. Compare. This one and this one. This one here is what we were solving just now. All the throughout, find the A, P, and Q, and what's not I'm solving. The other one is what we need to solve. What's the main similarity and difference here? Like, what's the same but different part here? You may tell me, oh, sure, the power like differ by 1, differ by 2, okay. Okay, this is one thing, but this one, okay, take a close look. I give you a hint over here. If this is power 3, this is power 0. In a way, you realize my power sort of switch position. They are swapped. Okay, so how do we relate here? You take a close look. Initially, I have 6. Suddenly, 8 pop up, I got y power 3. Take note, if I were to solve it, it's the same thing as saying, I got power 3 here. Suddenly, it disappears. I got y square here. Suddenly, my power reduced by 1. Okay, what do you think is the best way to get me from this particular polynomial to this one? To that form. Similar to that form. Okay, let you all have some thinking. I give you a hint. It's a very fundamental thought process of just your plus minus times divide. One of them will help you work to convert it similar to this form. I repeat, similar. Initially, P is the highest power. Take note, we want to make sure that it is of the same form as this. You are working with this polynomial. So we want to make sure that this one, in the end, when I manipulate my polynomial, I want to make sure I have P something power 3 plus Q something power 2 minus 29 something minus 6. This is our ultimate goal, to convert this to this so that I can use the hence part. Because I worked with this just now. Okay, I have to think about it. Okay, what's one thing I can do here? Anybody want to try? Okay, let me see. Let me summon a brave soul. La, 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 la. Yeah, I just random. I'm just going to see. Okay, Xander, would you like to try? I anyhow and I scroll down only. Try. It's okay. What's the one best way? This one suddenly disappears. My y2 suddenly decreased the power by 1. What is a best way? Sorry, I heard something. I heard divide by something. I heard some moments. Okay. Some of the answers are reviewed already. Whatever you're saying near here, what I'm hearing is correct. Okay, let me review. What I mean is as simple as just dividing. The only way to get a cube, which is one way as well, and a common trend, this is a common trend as well, is where? Because I have this. So you realize if your coefficients are written in the other way around, okay, where you realize everything inverts, like the one with the lowest power suddenly becomes the one with the highest power here. Okay, perform a division. Okay, that is one technique we can look for. Once we have this, you realize this is now your x, specifically this. So therefore, whatever is here, instead of x, it will be okay. So this particular thing where we are just dividing to make sure our powers revert back in the other manner is a common trend of technique as well. So common technique to use lah. So something to take note. Dividing by the highest power. Okay, can all good? Okay, give you some time to absorb this before I move on. Okay, all right, let me move on, yeah. Now, okay, I think at the point, at this juncture, you all are very sian of part A already. So I'm just gonna go, not skip, I'm gonna go and just blab out the common things you need to take note. Has a factor, leave a remainder, find the value of A and B. What we do, blue color method, f minus 1 is equals to 0. Okay, this one I better don't anyhow do. Negative 1 cube minus 4, negative 1 square, minus A plus B is a factor. This gives me negative 1 minus 4 minus A plus B. This gives me negative A plus B equals to 5. We arrange 5. B is equals to 5 plus 8. That's your first equation. Second part, leave a remainder of negative 60. Okay, so I have negative 3 cubed minus 4 of negative 3 square minus 3A plus B equals to negative 60. This is negative 27 minus 36 minus 3A plus B equals to negative 60. I'm going to have B. I bring my 3A over. And over here, 1 is equals to 2. Bring my negative 2 over. Okay, normal solving lah. Bring my negative 3A over. 5 the other side, I get A equals to 1. After that, with this value of A, you can check, sub into either equations lah. In this case, I like to sub to 1 because no multiplication. B is just 5 plus 1, which is 6. Okay, done deal. Okay, can? Typical notion. Next one, using the values of A and B, I will solve the equation. So I will solve with my values of A and B that I found, where A is 1. B is 6. Okay, what happens again? First step, if your equation is not labeled or is labeled as fx. Not to worry, okay? Remember the factoring part. Same stuff at this point. What is my factor? X plus 1. Okay, so x plus 1. As a result, at the end, what do I have? X squared. I have x cubed. I have x. What's remaining is x squared. What's at the end? I have 6. I have 1. My constant should be a 6. The remaining term I need to find is this. Continue solving from there. All right, you realize I'm comparing the same terms again. Comparing x squared term, let's say. I have negative 4. X multiplied to b, that's the first one. The other one, I have 1 to x squared. Following this along the way, I get b is equals to negative 5. Therefore, my polynomial I'm getting is fx, which is what I've solved just now, is just x plus 1. X squared minus 5x plus 6. Okay, you can take your calculator, punch, same thing, find the values. Okay, but this will actually just garner you. Calculator or multiplication frame method, it will get you this. When you solve, in this case, you are just solving for this one. Henceforth, x is equals to minus 1, x is equals to 2, x is equals to 3. Done deal. Okay, same stuff here. Now, I think you're all more interested in part 3. So as you are writing down B, take a look, part C. Take note, they ask you to explain, so please do not solve.
That's deja vu, but I thought this can't be true because
Over here, for part C, one common trend is this. All right, if you realize one of the bases and the other base over here is squared, in this case, looking at this, tell yourself a potential quadratic or cubic equation is coming. Why so? Rearranging, this is what I get. The negative part, it goes down. Okay, these are your indices rule. Okay, common trend, if one of the base is twice of the other, we can rewrite like this. And as you manipulate, take note how the solution from part B, your polynomial will be related. Check here, compare. This is the original polynomial that you have.
I'm coming back. You can see it. It's the greatest that you can see it.
Try to see how is it related to the part here.
I lost it. Yeah, you held my hand, but I tossed it.
Carry on and solve. You just multiply throughout. So I have 3x cubed plus this big 3x. 4 of 3x squared minus 6. You realize if you were to manipulate and bring everything over, the one that is cubed, the one that is squared, is really the same as this one now. Just that it takes up the row of this. So if I can have a continuation of this question, it can be hence solve this lah. But I don't need you all to solve this, to explain. Okay, so don't go ahead and solve this. You realize this is already a trend whereby this is your big X. Okay, I'm just writing your big X here. What happens? Now you need to explain. So basically, how the solution can be solved, you just say how the solution. So in this case, instead of x equals to this from the solution,
关键是数学要做，就是我把它放进 file 里面。
this way, where this is the scenario.
啥都
We
有，
are just taking over the row.
华文、英文、华文、科学，
没有法文，
没有华文就是
有
物理、化学，
有，
这些都是属于学校练习的
这是你外面印的，
啊，就是都是给你们练习，不是要教的啦。需
他
要教
可能要你要讲
Any questions after this point?
改，
不会教你们啦。
Anna?
他会讲啦。
Now understand the next part can be quite tedious and henceforth quite repetitive. So this is where I get your feedback. Do you want me to do partial
Okay.
fractions or go straight to
不是
quadratic
不
functions
需要
for
教
you
啊。
all
对啊，
instead
不
of
用
rushing
教。
through the
我
content?
问的就是需要
Because I know partial fractions. How many of you have issue with partial fractions?
对，就是说你下个礼拜二要教，
没有
下个礼拜五要教啊。所有爸爸问你是练习的嘛？
No, no, I'm not stopping the class. I'm just saying how many of you
要
have issue with partial
那
fractions.
个你做完那个
那个
书包
书包那个啊，
And
好吗？好吗？你看，nice right
都是的。
right，
okay,
你看我还放这边。
don't worry. The stuff that we did not really go through, I will give you all the solutions. So I'll print it out and give you all for you all to try.
衣服
啊
Okay, it will be sent to your online in particular. Okay, I will collate for you all. Which ones you all want me to touch on at this point? Quadratic functions? Or anything? Sorry? Quadratic, okay. Because I realized that, okay, I apologize if I'm a bit naggy. Okay, so partial fractions can be a little bit quite repetitive. So I will move on to quadratic, okay. Okay, so the partial fractions part, okay, I will craft out the solutions and make sure I send it you all through online, because unfortunately I don't have the solutions with me now. My apologies. So let's move on to quadratic. Okay, when we finish up that. Okay, just get attention for a while, yeah. Quite a bit. Okay, come, guys, just need your focus here. My apologies, yeah. First one, when we talk about quadratic functions, calm down, calm down. The first part towards solving quadratic inequalities, okay, is usually the steps to solve. Usually what happens, the steps are very similar to solving your quadratic equations. What do I mean? What we will do, we will expand and rearrange if needed. So basically, when you do this, we want to make sure our right-hand side is 0. After that, usually for your case, we will factorize this part. It is usually factorizable. These will be your roots. Okay, however, when we sketch out the graph, take note, we need to note the shape. In this case over here, the coefficient is more than 0. We have a smiley face. Take note, more than 0 over here in this case, and here, that's why I'm shading up. It's because I'm looking at the upper part of the curve. In this case over here, since it's more than 0, I'm shading above the x-axis. This part. And that's why we are looking at the left and right. Okay, in summary, just a quick review. Now, in this case over here, quick one for a quadratic function. This is a different style of question. Why would I say that? A quick one. I give you the solution. I want you to find out. How do we do so? From here, y is less than 0 when I have this. Take note, this is my original function. Any parts not sure? Draw out the whole thing. Realizing when you solve the inequalities, my endpoints here, these are your
31, 32, 33.
roots, right? So what happens to these roots? This is going to be a
What do they eat at home?
smiley face, definitely. And my roots are 2 and k. These are my roots. Okay, and we know it's less than 0 over here. This satisfies the question here. Okay, now from here, how do we continue on? We know to get these two roots, we have to get it from this way. X minus 2, x minus k. This is the scenario for me to get the particular polynomial when it is less than 0. However, you realize this does not satisfy this yet. Why? My x squared coefficient is 2. I cannot get a 2 over here. So one way to do so, This one you expand, you realize it gives me x squared. How to get the 2? We introduce a 2 outside. Just multiply. From here, what we usually do, we will expand as per norm, x squared minus kx minus 2x plus 2k. This one, why are we expanding? Is because, okay, we expand the inside first. We are getting minus k plus 2 x plus 2k. This is less than 0. Expanding the 2 in. Why are we expanding it in? Because take note, where we get the solutions from is equating this part over here. We are solving this quadratic equation curve here. When it's less than 0, it gives me this. So I'm reversing my way here. This is this part. Okay, do you all see that? Okay, any parts not sure, let me know again. So in this case, if we compare, correct, I think I hear some correct things. 4k equals to 16, k is equals to 4. And then you realize in this case, I have my p, comparing it with this term. P is negative 2, 4 plus 2. That's where you get. So this is another convention where instead of asking you to solve directly, it is going the reverse manner. I give you the solution. You backtrack your way to get the original polynomial. Okay, any questions? Any parts unclear? Okay, press on. Now, one common thing when we talk about your quadratic functions is this thing called your discriminant. Okay, and why discriminant in this case when we say it's more than 0, 2 and real distinct roots, equals to 0, it's 2 real and equal roots. Last one, less than 0, no real roots. Okay, it's because you will take a close look, discriminant is just a value. It's inside a square root. More than 0, I can evaluate the square root. Therefore, 2 solutions. Equals to 0, I will have. Therefore, only 1 solution. Less than 0, I cannot evaluate this at all. So, in case if you are wondering how to link your discriminant to my stuff, this is how we can take note. More than 0, 2 real roots is this one. Equals to 0, only 1 value. Less than 0, I cannot evaluate my square roots. Therefore, no value symbol. Okay, so these are, I understand that you all know your discriminants, but these are just some keywords you all can take note if you want to know how you link your discriminants to these things here. Square root. Okay. Once we have this, applications of discriminant, usually you will have one way, line and curve. If you have 2 intersections, your discriminant is more than 0. If you have intersecting any at one point, it touches at one point, it is a tangent to the curve. Last one, if it's floating, there is no intersection. One key thing over here is when they say the line intersects the curve, take note, it must be a non-strict inequality because it can be 1 or 2 intersections. Okay, non-strict inequality because when I say intersect, it can be 1 or 2. Okay, So it's something to take note lah. Second style, always positive or negative. Take note, this one key trick, especially for this one, because I know when you talk about always positive, immediately I know this will happen. Take note, this is not the case. Because if it's always positive, or in this case, regardless, always negative, I will always have no roots. To be always positive and always negative, take note, no roots. So no roots, we call my discriminant is less than 0 to ensure that it's either floating up or floating down. Sorry, always positive, always negative. Okay, always positive, always negative means no roots. That's why linking to b squared minus 4ac less than 0. So don't get confused. I know, especially for this one. The second one, you all will follow the trend, no issues. It's this one where you all will get confused. You all will tell me all bigger than 0. So take note. Okay, one example over here. It's always positive. If you are confused, you can draw the diagram. This is the only way for it to be positive. Once you draw this, everything is clear. We know this is more than 0, but discriminant is less than 0. So you form your b squared minus 4ac below, and in this case over here, following the inequality when you solve, that satisfies this and this, because I need it to be positive and satisfying this. It must be this scenario, but we answer the question, least value of the integer, 3. Because 5 over 2, 2.5, I want an integer that is 3 lah. Okay, can so all these thought processes will come, but you must draw the diagram first. Just a rough diagram. And just bear with me, hang in there, yeah? Now, this is where all your typical question comes in. First thing, intersects 2 distinct points. Discriminant will be more than 0. But before you apply the discriminant, what must I do to these functions? We must equate, right? So, in this case, first one, this one we rearrange. Second one, we have okay, so this is equation 1. This is equation 2. We sub 1 into 2. Okay, maybe I skip a step. I square both sides first. So I have x squared equals to kx minus 9 minus 3x. Simplifying a bit more, x squared equals to kx minus 9 minus 3x, bringing everything over. And all in all, take note, I'm solving for the range. The best way to do so, discriminant. So I have is more than 0, because 2 distinct. The keyword is distinct. So in this case, I have 3 plus k squared minus 4. Yes?
It's supposed to be negative. Because when you bring it over,
Negative?
you can add the x squared plus.
Alright, thank you for the note. So it's 3 minus k, right? Yes. Okay, so just the sign. Thank you so much. So 3 minus k Sorry for that, more than 0. So I expand. And then simplify from there. K squared minus 6k minus 5. All in all, you are solving this particular quadratic expression. Check here. Okay, let's check. It's plus 5, sorry. Check here. Okay. This can be broken down into minus 1, minus 5, more than 0. If you need to, draw a diagram to visualize. This is 1, this is 5. I need it to be more than 0.
It's still b squared minus 4 is you only wrote minus 4.
Okay. Yes. There should be a 36. Give me a moment. So sorry. There should be a 9 here. So there is a 36 here. So sorry for that. And in this case, this is negative 27. Negative 27. So sorry, Okay, then this one will give me negative 9 and positive 3. Okay, after your factorization. Ultimately, your curve won't change. This is what we need to take note. All right, thank you for verifying for me. Okay, but the concept over here is, okay, intersection, 2 distinct points, straight away discriminant, working will flow throughout. Yeah. Okay, any questions? All good, yeah? Lies entirely above. This one, discriminant, are there any intersections? Lies entirely above, right? So we know this tells me if I equate them, x squared equals to x plus 1. This is x squared minus kx minus k. If I equate this and I try to find my constant entirely above my discriminant, in this case over here, which is b squared minus 4ac less than 0. I have k squared plus 4k. This is easily factorizable in this scenario. Draw my curve, same stuff, discriminant. Okay, this is negative 4, this is 0, this is below. Okay? Because of the word lies entirely above. And now just bear with me. I know it's hard. You guys are zoning out a little bit, but just bear with me. I will almost there. Okay, can Okay, now third one. This one, okay, there is a trap in this question because when y'all do this, I know first step y'all will do this. Correct, right? Not wrong, right? But I say if you all write this is wrong. Why? You are supposed to explain why this is less, more than, or equals to 0. You cannot assume. So please don't happy, oh, discriminant question, more than 0. Please no. You are supposed to work this out with this particular thing down here. So take note for this question when you see explain why, please tell yourself maybe a note, don't do this. No, don't write it first. You are supposed to work out, okay, my discriminant b squared minus 4ac, let's work out, this is equals to 4a squared minus, in this case, 8a squared minus plus 12b. Okay, this is negative 4a squared plus 12b. Okay, then maybe some of y'all may get stuck here. Okay, and then you realize, oh, maybe I tried to factorize it out. And then you realize, okay, how is this going to show me that this is more than 0? That is where you use this part. Okay, this tells me so since this is more than 0, we should need to write it down. Okay, the explain part. Therefore, my discriminant is more than 0. And I have 2 x-intercepts. Okay, this third style of the question, please take note, do not, I repeat, do not assume it is more than 0 first. You are supposed to work this out. Okay, all good? Yeah. Okay, all clear? All right, press on. Few more variations. But what happens? A bit different. Tangent to the curve, then otherwise, when you look at this, you all are stunned. But what happens? What's the common trend of consecutive numbers? 1, 2, 3, 4, 5, say for example. If I talk about consecutive numbers, they will differ by 1, right? So that means either, when I actually do it, either I want to say that one of them is bigger than the other one, or this way. Doesn't matter. This is the trend I need to see at the end. Tell yourself, if this statement is hard to see, break it down in terms of mathematical expression. So it's easier for you to see. Okay, so from here, we are equating. So we have 3x plus p equals to x squared plus 5x plus q. Shift all to one side, I have x squared plus 2x plus q minus p. Tangent to the curve, my discriminant is equals to 0. Therefore, b squared minus 4ac is equals to 0. Work this out. This is what we want to get. That's our end goal. 4 minus 4q minus plus 4p. Divide everything by 4. What's the trend we want to get? P is equals to q minus 1. Or in this case over here, maybe working it out, q is equals to p plus 1. That's right, q is equals to p plus 1. It is one of these scenarios. We are done. If you want to write q is equals to p is equals to q minus 1, it's fine as well. They all differ by plus minus 1. Doesn't matter. Okay, that's the trend. Okay, how will we explain this? Sometimes this is not enough. Okay, usually when you have an explain question, we need to write a statement. So what we can say is, since P and Q differ by 1, okay, and substantiate also consecutive numbers, literally state the facts between consecutive numbers and the fact here to write your conclusion. Okay, we do it this way. Okay, why my statement is phrased this way? This is this fact, and we know this in general is what you told me. These are how your okay, got it down? So as you go along, as we try these questions, tangents to the curve, two intersections to the curve, all right? The end result, okay, Billy is noting down how you're writing your mathematical equations. They'll work out from there. Okay, but I realize the common trend is always tangent to intercepts does not intersect. Okay, it's always these scenarios. Okay? Press on a little, just two more. Okay, next one. First one. Tangents to the curve. C is equals to half. Okay, so literally they tell you the value. Y is equals to mx plus 12, half. Okay, tangent to the curve when I'm equating mx plus half equals to, just bear with me guys, yeah? 4x minus 2x squared. Tangent to the curve, when I equate these two, let's say I multiply by 2 throughout. Eight x minus 4x squared. I bring my 4x over. Okay, tangent to the curve, yeah? So my b squared minus 4ac equals to 0. Okay, so work it out. B squared minus 4ac equals to 0. Now over here, I urge you all not to expect. You have a complete square. Right hand side is a constant. So a trick is this. If you are able to get it to this form, do I need to expand? Something square is a constant. Straight away, square root. So heck, no need see everything square expand, because if you have something square is a number, we can square root it, straight away give me the constant. This gives me 2m minus 8 equals to 4. Try to make sure you are lazy efficient. Okay, quote me, lazy efficient in terms of your working. Yeah. Part B, same scenario, 0, 1 or 2 points or intersection. Again, working with my discriminant, but just that right now I am working with this equation where my C is equals over here. Okay, I don't know what is it, but I know my C is this. So from here, we arrange everything to one side. Okay, flipping it out. Take note, in this case, I'm working out for my discriminant. They want you to show. So you're not supposed to tell me whether the discriminant is more, less, or equals. Work out the function of my discriminant. In this case, I have b squared minus 4ac. Okay, work this out. I have over here, b square minus 4ac. M minus 4 square minus 8c. Okay, so you may wonder whether I should expand. Take note, I have a negative y-intercept. Tendency is when you have an expression like this, keep it as such. Let's check. If I have a negative y-intercept, check with the expression. Okay, what will my discriminant be? Okay, so my discriminant, if you were to work it out, okay, how do we prove it? First, use our known fact, m minus 4 whole thing squared. What is it about? We know this is always more than or equals to 0. C is always less than 0. Bringing it over, multiply by negative 8 will be more than 0. Adding up two positive terms, what will this give you? More than 0 in the end. So therefore, since we can justify this is more than or equals to 0, I know this will have two intercepts. Yep, C is a negative number, so negative and negative will give me positive. Okay? Can Okay, I understand right now you all are quite shagged out. If I were to go through the next question, your brains will fly. So what happens? Last question, I will write out the solutions. I will send you all respectively online. Just message the admin for the solutions if required. Okay, they will send you the solutions accordingly. I'll work it out. Okay, Ken. All right, thank you for bearing with me. Just some formalities. Understand the session is a little bit rushed, but if you feel it kind of help you, if you want some foolscap paper, just scan a review, QR code. Okay, let me see. I can give you all a foolscap pad if you all want. Up to you all. No obligations. Okay. I know some of y'all, when y'all are scared, y'all can see this, but y'all must let me see. Okay. And y'all know lah, 5 stars review and all. But again, really, ultimately, your point is you must get you must be able to understand key thing. Okay, must let me see lah. Okay. Okay. I apologize once again if the session is a little bit rushed, but I do hope you take a little something from this. Math, I understand it's a bit dry, but I really hope you take a open. Take note, here is Novena. You don't show me Marine Parade, what's not. I tell you, you go Marine Parade, you go Marine Parade settle. Okay, next thing also. This one, again, I think some of you have seen this, but reminding you all, okay, for those who are seeing this for the first time, okay, you have no, you don't need to lock in anything. You don't need to pay anything. This one is really to lock in your interest if you're interested. If you're okay with this class, you're interested, all right? Okay, you can do so by registering through scanning this and register. You don't need to pay anything. It's to lock in for early interest lock. So you have no loss. Okay, can so I'll be this screen there. And also, if you're interested in this class over here, all right, this is for set 4, sorry. Okay, for next one, IP4, I do have 1 class, Novena 5 to 7. So if you're interested next year, feel free to take in note. But again, all in all, is really for y'all to see whether this benefits you. Okay, I don't want to enforce. Okay, this is the timing lah. Okay, so check lah. Okay, so this is the timing. Okay, let me know what y'all need to scan and stuff. Just let me know. Okay, let me see. Yes, I'll send the answers PDF. Okay, just ask the admin. The admin will send you QR code for the PDF with answers. Oh, no. As in the QR code is for the staff. I will do up the solutions and I will send it. Okay? All right, so let me just go here. Anything? Otherwise, thank you for your time. I apologize for not finishing all the questions once again. But the main point over here is I do hope you all have some takeaway. That is my purpose over here. If you have some questions, please let me know. Otherwise, if you want to claim your foolscap paper, please let me see your stuff before you all leave. Okay?